Hey everyone, welcome to another session of Ceerazzledazzle Physics. In today's session, we're going to be talking about weight, mass, and gravity, guys. So put down today's title, it's going to be weight, mass, and gravity. Before we get started, make sure you hit the like and subscribe button to keep my channel going, and obviously keep my content as free as possible to make learning, as easy and accessible to everyone. Right, so first of all, let's talk about it. What exactly is the difference between mass and weight? What is the difference? Well, first of all, guys, weight and mass are not the same. They are simply not the same thing. A lot of people get confused. They think weight and mass is the same thing. They are not the same thing, guys. That's the first thing to get into your head. So make sure you understand that. If someone says to you the word weight, it's not the same as the mass. So what exactly is the mass? That's what we're going to be talking about today. The mass, right. So mass is the amount of matter an object has. It is the amount of matter an object has here. Mass is measured in kilograms, guys. So make sure we get that down. Mass is measured in kilograms. And obviously it's going to be capital K, lowercase g for kilograms over here. Your mass remains the same throughout the universe. So that means wherever you go in the universe, your mass will remain the same. It won't change. Good example is going to be at the bottom over here. If my mass on Earth is 80 kilograms and my mass on the moon is going to still be 80 kilograms. And on Jupiter, it will still remain 80 kilograms, guys. So the mass remains the same whichever planet that you are on. That's the first thing to get into our heads. And obviously it's measured in kilograms and it's the amount of matter. Right, so what exactly is weight? How is weight different to mass? That's the thing that we're going to be talking about today. Well, the first thing to note is that weight is a force. So mass is not a force, but weight is a force, guys. So weight is a force. It is measured in newtons, guys, or capital N. Don't forget, you write down the word newtons lowercase or capital N for newtons, yeah, if you want the symbol here. Your weight will change depending on which planet that you are on, as the gravitational field strength will vary. So your weight will change if you go to different planets. Not the same as the mass, your mass remains constant, but your weight will change depending on which planet that you are on. Next, last point, guys, is going to be it's a force. So don't forget forces, guys. So let's just say I had like a person over here. There we go, there's my person. The weight of the person obviously is like a force, so therefore the force is going down here. So don't forget forces have a direction, and if you have a direction, we know you are a vector quantity, guys. So you're a vector quantity. And if you don't know what a vector quantity is, a vector quantity has size and direction, guys. Vector quantities have size and direction. Okay, now moving on from here, we're going to be looking at how we can connect the mass and the weight. So we know what the weight is. Obviously, it's a force measured in newtons, and your mass is going to be the amount of matter measured in kilograms. And obviously, your weight depends upon the gravitational field strength, and your mass does not. Right, so let's connect them both with the following formula. Right, so as you can see, guys, weight over here is equal to the mass times by gravity. Weight is equal to mass times by gravity. So weight we're going to say is W, mass we're going to say is M, times by G. Okay, so as you can see, W is equal to M times by G. Those are the symbols. You've got to identify the units of the equation. So the weight is a force, so therefore it's measured in newtons. Mass is going to be measured in kilograms. And the last of all, we have the gravitational field strength, which is newtons per kilogram, guys. So newtons per kilogram, those are our units over here. Okay, guys, so now we've got this formula into our heads. Let's look at the following scenario. Example question. Calculate my weight on each planet. My mass on Earth is 80 kilograms. Okay, so your task is to calculate my weight on different planets here. As you can see, I've got the moon, I've got the Earth, and I've got Jupiter here. And there we are, that's me, 1, 2, 3 on each of the planets here. Right, so first of all, if I want to calculate my weight on the moon, first of all, I just write down W is equal to M times by G. Weight is equal to mass times by gravity. The weight is obviously equal to my mass. My mass remains the same, 80 kilograms, times by 1.6. Therefore, my value of the weight is going to be, so 80 times by 1.6, I'm getting 128 newtons. So my weight on the moon is 128 newtons, guys. Next one, so let's say on Earth, we can still do my weights right now. Weight is equal to the mass times by the gravity. My mass is going to be still, don't forget my mass remains the same, whichever planet I'm on. So it's going to be 80 kilograms times by gravitational field strength. Look, gravity on Earth, guys, is given as 10 newtons per kilogram, guys. You can remember that because it just obviously makes your calculations a bit faster. That gravity on Earth is going to be 10. That's a nice bit of trivia for you as well. So 80 kg times by 10. Therefore, my weight is going to be 800. Don't forget the units. Newtons, everyone. 800 newtons over here. Last of all, we've got Jupiter. Jupiter over here. Let's do the same equation again. W is equal to m multiplied by g. Therefore, the weight is equal to my mass. My mass remains the same. Don't forget, 80 kilograms times by gravity. Gravity on Jupiter is, guys, 25 newtons per kilogram, guys. So it's going to be 80 times by 25. We're going to get 2,000, guys. So 2,000 newtons. And look, guys, we can clearly see that. Look, my mass remains the same on every planet. Look, my mass is the same everywhere, but my weight is going to change. And obviously, it changes based upon the gravitational field strength of that planet. And look, you can make a simple conclusion here. Look, the greater the size of the planet, the greater the gravitational field strength. As you can see, guys, that we can see that on the moon, my weight will be the lowest. Obviously, the moon is really small. The Earth, my weight is going to be a bit higher because obviously the Earth is greater than the moon. And last of all, Jupiter is going to be really, really massive. Therefore, my weight is even higher. So the gravitational field strength is obviously proportional to the mass of the planet, guys. So the greater the mass of the planet, the greater the gravitational field strength, and therefore the greater the weight. Okay, so we're done for another session. Let's have a recap right from the top, guys. Right, so today's title was weight, mass, and gravity. And then we talked about weight and mass are not the same. First of all, that's the first thing to get into our mind, that weight and mass are not the same. Mass is the amount of matter an object has, and mass is measured in kilograms. Your mass remains the same throughout the universe. Wherever you are in the universe, your mass remains the same. Good example, my mass is 80 kilograms, so on Earth it's 80 kilograms. You take me to the moon, it's 80 kilograms. You take me to Jupiter, my mass still remains 80 kilograms. So from there, we then talked about what on Earth is weight. Weight is a force, and obviously forces are measured in newtons, guys. So weight changes depending on which planet that you're on, as the gravitational field strength varies. So if gravity is going to change, obviously your weight will change here. And it's a force, and therefore it's a vector quantity because it has a size and direction, guys. It has a size and direction. Right, and as you can see in that little diagram over here, that my weight is always pulling me down, obviously to the center of the Earth, guys. Then we talked about the formula. The formula is equal to weight is equal to mass multiplied by gravity, or W is equal to m times by g, where W is in newtons, mass in kilograms, and gravity in newton per kilogram, guys. Right, so obviously make sure you get the units right. Weight is obviously newtons, mass is in kilograms. From here, let's move on. From here, guys, we then looked at the following scenario. I said to you guys, calculate my weight on different planets. So obviously, I've put the value of gravity on each different place. The moon, it's 1.6 gravity. The Earth, it's 10. The gravity on Jupiter is 25. I said to you guys, calculate my weight on each planet. Obviously, look, I used the formula, W is equal to m times by g. My mass is the same on each planet, but obviously gravity is changing, so therefore it changes my weight. So my weight on the moon is 128 newtons, my weight on the Earth is 800 newtons, my weight on Jupiter is 2,000 newtons, guys. So obviously we can see that the greater the size of the planet, the greater the gravitational field strength, and therefore the greater the value of my weight. And that's it for another session of CeerazzleDazzle Physics. Make sure you hit the like and subscribe button to keep my channel going, and ciao ciao and good luck in your studies. Goodbye.